Similar to time series data, we can also check for the presence of a unit root or non-stationarity in panel data. And there are a lot of tests that allow us to do this. To do that, I have mentioned some of them, like first generation unit root tests, so let's say more simple ones. And those are the tests that are available in, I would say, in all the econometric software. And there are also some more complicated unit root tests, like second generation unit root tests, and I've mentioned one of them, CIPS. This is the test that has been developed by Pesseran. So when it comes to the first six tests, as I said, they are available in most of the econometric software. However, when it comes to second generation unit root tests, unfortunately, they're not that easily available everywhere, and you will have to find a special software that will allow you to apply this test. But I think it's always good to start with some simple things. So if you learn how to apply these 6 tests, that will be for now more than enough. And we know that after we've checked for unit root and after we have found that our variables are non-stationary, we should also check for cointegration. And again, there are a lot of cointegration tests that allow us to do this in the case of panel data. And the most common one, the most famous first generation cointegration test, it's Pedroni residual cointegration test developed by Pedroni. There are also now more advanced tests that take a lot of issues into account, and they're all called second generation cointegration tests. And I have mentioned one of it, Westerland's cointegration test, which has been developed by Westerland. So again, the first generation cointegration test is easily available in, I would say, in all the econometric software. However, if you decide to apply second generation cointegration test, then you will need to look for a more advanced econometric software. And now let's move to the estimation of our econometric model. So when it comes to panel data, there are 3 cases. The first case, the simplest one, is when the variables are stationary. So for example, you do unit root test and you find that all of your variables are stationary, so they don't have a unit root. Then you can estimate your model using one of the 3 estimators that I've discussed before, like pooled OLS, fixed effects, or random effects estimator. However, most probably you will find that some of your variables are non-stationary, so they have a unit root, but for example, they're not cointegrated, so they don't have a long-run relationship. So in this case, first of all, you will need to make a variable stationary, and to do this, you will have to apply first differences, or if they don't help, second differences or higher differences. And once you've done this, you can estimate the model using the previous estimators like pooled OLS, fixed effects, or random effects estimator. And the third case, the most interesting one, is when your variables are non-stationary, so they have a unit root and cointegrated, meaning they have a long-run relationship. So if this is the case, there are 2 options available. The first one, the simplest one, is estimating the model using fully modified OLS or dynamic OLS estimator. Those are the estimators that are available in most of the econometric softwares, so I don't think you will have any issues with this. And the second option, the more interesting one, is constructing and estimating error correction model, so similar to the previous lecture on time series data. So if you want to do this, you can consider one of the following estimators for your model. For example, dynamic fixed effects, mean group, pooled mean group, or the most recent one, more advanced one, is common correlated effects mean group estimator. However, if you decide to estimate an error correction model using one of these 4 estimators, you will have to use one of the more advanced econometric softwares. Please be aware that this is a very strict generalization of the reality, and it might happen that your variables suffer from autocorrelation or heterogeneity. In this case, you will have to use other estimators, like, for example, generalized least squares or instrumental variables or generalized methods of moments. However, those techniques are not a part of this course, so we're not going to discuss them. Therefore, at this stage, those are the 3 cases that you should be familiar with.